Okay, let's go ahead and get started then. Um, so as you can tell, today I'm back in my office, which is great. I have no idea what's going to happen on Friday. I'm supposed to be in Denver in the morning, but I think I'll be back in time. If not, I'll be trying to dial in through the phone or something horrible. But anyway, what I want to do today and also Friday is continue our discussions of abstraction. Okay. So last time we talked about abstraction in terms of a variable, mostly being what information do you need to have in order to be able to do a particular program. Okay. And I think that's important. All right. But I kind of want to broaden that discussion a little bit today. So one of the things I asked you last time was about computing the GPA. And you guys correctly identified that to compute the GPA, you needed to know your grades in the different classes. But you really didn't worry so much about other things, like exactly what the classes were, right? But instead of just your GPA, I want you to think about your transcript, okay? So for example, let's say that I wanted to have a your transcript, which is all of the courses that you've taken, that you're currently taking, and the official grades that you've gotten, and the ones that come from past semesters. And write a program that does things like, say, check for graduation. Can you actually graduate from high school based on those courses? Or maybe something like, do you qualify for the Hathaway Scholarship based on those courses? So let's see, what can we look for that? This is what it should look like, okay? Let me see. I'm going to share one of my other screens. Okay. So can you see the screen that I'm sharing? It should just be like a white blackboard. Excellent. So what I want to have is something that looks like this. Algebra 1, and that was an A. And I actually need to know that this was a math class, okay? And I might have English 10, and that was a B plus, and let's say that that is an English course. And let's say we have biology 1, and that was an A minus, and this is a science class, okay? And we'll add psychology, and that was an A, and this is a social studies class. And of course, there might be a whole bunch of these, okay? Those are the courses that you're taking. Now, the reason that I need all this information is that I may need to have requirements such as this: 4 years of math, 3 years of social science, 4 years of English, and so on, right? So I get the entire set of courses that you're taking, which is called your transcript, and I can now examine it, right? So I can determine whether, yes, you qualify for whatever. All right, so now this is what I want to get to is how do I store something like that, okay? Because there's 3 pieces of information that I need to store. I need to store the class name, I need to store the grade that you got, and I also need to store what kind of class it is. And the answer, at least in SNAP, is that we're going to store this in a list that has 3 elements, okay? So if you go over here, oops. Okay, that's the place where we can actually store this. So algebra 1, Forgot what I said, but let's say it was an A, and we decided that this was a math class. Well, that doesn't read right. Let's try this. Right, and so on. So these are lists, right? And they let me store multiple pieces of information in the same place. Okay. Now the thing that I really want you to appreciate is that I have a whole bunch of lists that all look alike, right? They all consist of a name, followed by a grade, followed by a topic, or a category, if you will. Okay. Now, you and I know that the way to get the name is to get the first item of the list. The way to get the grade is to get the second item of the list, and the way to get the topic is to get the third item of the list. But that's awkward at best. Okay, so we can actually do that. And if I execute item 1, I get algebra 1, which is the first element of that list. Also, the name of the class that we're dealing with. Okay. What's nice about this is that it doesn't matter which class I'm talking about. It's always item 1 that gives us that information. So we have an abstraction. Item 1 of blank is actually the name of the course. If I put in here 2, then what I start getting is the grade. Right? Item 2 of the course is the grade. And again, it doesn't matter what I store in there. Item 2 is always the grade of that class. That's the point of abstraction. Okay. So the lesson here is that with a list, we can actually get a degree of abstraction because the different components of the list can have different meanings. And we just know that item 1 is this meaning, item 2 is that meaning, item 3 is that meaning, and so on. We can do better than that, and the lab that I ask you to do actually does that. So you can actually have a block that might be called grade of course. And I'll change the course to be an input name and specifically of a list. Okay, and now what it needs to return is just item 2 of that specific course. So now grade of that algebra is A, right? Which is, so this is actually going up in the levels of abstraction. We had a list, we knew that the components of the list have special meanings, and now we have a block that grabs that information out of a list. That's pretty nice, okay? As you know, I believe you can appreciate, right? Although, you know, you may feel that you can keep it in your head, so there's no point yet, okay? But I believe that you can appreciate that having a block called grade of this will be easier to get straight than remembering item 2 of list everywhere, okay? So that's the advantage. Some of you have asked me about things like Java and object-oriented programming a lot. This is actually what in object-oriented programmer you'd call a class, or you call a record structure, okay? So that's definitely an abstraction. Now, the second bit of abstraction is this. I have all these courses, and I can put all of them in a list, okay? So what I'm actually have is a list of courses, and this is just a ordinary course. So if you will, this is abstraction number 1. And this is abstraction number 2. What's nice about having a list of courses is that I can now process all of the elements in that list without needing to worry about individual things. So for example, I can actually do a transcript. That's just a list of courses. And I can do all sorts of things like check it for scholarships, graduation, honor society standing, anything else that I want, right? And all of those kind of have the same input, which is a list of courses. And there we have a really nice abstraction. So, the lab that I'm asking you to do will eventually ask you to do things like this. Well, you'll draw a shape like that, okay? Okay, and the way that that this is drawn is by having a list of points, x comma y, and then putting those in a big list. So I now have x1, y1, x2, y2, xn, yn. Okay, and the point just has the coordinate, and so your program simply goes from one to the next. Okay, notice that I didn't get the guys in the middle, right? Why couldn't I get to those? It's because I had to lift the pen to be able to move there, okay? So this abstraction, okay, is actually only good enough for connected paths. Okay, and that's actually what the lab asks you to build. But I'm going to throw out a challenge at you, and that is figure out how to do these not connected paths. Okay, and I'll ask you right now, because there's kind of two ways of doing it. One of those is to put an extra item there, which basically means pen down or not. Okay. You might think about that, okay? That's obviously no longer a point. That is something else, okay? So that might be a way of solving it. Another way of solving it might be to have a list of instructions. Instruction 1, instruction 2, up to instruction n. And what an instruction might look like is a list that might say, for example, move x, y. Right? This is actually very similar to that first idea I gave you, but what's different is that instead of just trying to remember, do I want to go leave the pen down or up when I go to this point, we now actually abstracted that to the concept of an instruction. So now you can say list of instructions as opposed to list of points with a flag telling me whether the pen should be down or not. Okay, so that's again, these are equivalent abstractions, but I would argue, and I want you to think about this, that this is a better abstraction because it's more cohesive, right? I can actually describe it as a list of abstractions as opposed to a list of instructions as opposed to a list of points with one extra bit of information. All right. Anyway, this is another way that you can abstract in your program. What we have is the data that you need, but in a way of collecting it that you don't need to know as much. Meaning, before you would have needed to know exactly how many points I need to go over, right? If you don't use the list. If you do use the lists, then if nothing else, you can say, and you know what? I've actually got what's the word I'm looking for? Well, you can have as many points in your shape as you want, okay? And there's a great benefit to having that. Okay. All right. Okay. Let me. End kind of this discussion by talking about what we've done with abstraction. Kind of at the first level, we have variables. and these represent something. And that's why it's an abstraction, right? You know, the variable is actually standing for something else. We talked about procedures. And what this do is they encapsulate. That's just a fancy word for abstract, okay? They encapsulate some sort of functionality. And 3, we talked about lists of different things. About something. Okay, these things are called records in other languages, or objects. Okay, and what those are is you know, the list that has the name of the class, your grade, and the category of the class. Okay, and we want to be able to have that so that we can store lots of information that's closely related. Okay, and now finally 4, we have list of the same thing. And what we have here is the same functionality for lots of data. So just kind of to end that discussion, I happen to have the game of Galaga in my basement. And I like to go down to play it every once in a while. And if you haven't seen this particular game, you have a spaceship at the bottom that is shooting at a whole bunch of alien things that are flying down from the top. Okay. How many alien things? I've seen like 40 at a time, right? And I'm just guessing at the number. Maybe it's 50 or 60. The point is that each one of those alien things has a current position, right? It has a direction in which it's moving. It could be moving left. It could be moving right. It could be doing one of those weird things where it comes down from the top and attacks your spaceship. Hey, if I need to display that thing, right, put it in the right position, that's exactly the information I need. I may also then need to say, update the position for the next screen, right? Notice that that list of spaceships, I assume that is a list, okay? Lets me do that abstraction very, very nicely, right? So that I don't need to worry about, do I have 10 enemy ships? Do I have 50 enemy ships? I need to do very similar code for 50 different guys. I can simply do it in a loop, right? Going through all the elements of a list, each one of which is an enemy ship, okay? So, so that's an example of using lists in this way that you've undoubtedly run across. Okay, I'm going to leave that the discussion for today. Okay, we've done this for. Next time, I'm going to add kind of the largest one of all, which is you know, from wires to code. Okay, so this is like multiple levels of abstraction. And I will either do that on Friday or on Monday, depending on where I am at class time. Okay, I'm sorry, or on following Tuesday. Now, any questions about this abstraction? I mean, I want to make sure that you can see abstraction pretty much everywhere you turn. Okay, I'm going to stop there. Okay, what I want you to do the rest of the class is to finish the lab that you have. I believe it is U2L2, although I don't remember the exact name, but the one that we're doing this week. I want to see if we can get that finished today, if not definitely today and Friday. And if you have any questions, get back to me and we'll try to answer those. Okay.